Yeah. So good afternoon, everyone. Uh, Last class, if you see, we discussed about what are the different dimensions of the intelligence. In that, broadly, we covered six different dimensions of intelligence. In that, we covered cooperative, adaptive, reactive, personality, human-like interaction, and autonomous. So, in each case, we discussed elaborately. At the same time, you have practiced applying different dimensions of intelligence on dining table to define or to introduce the concept of smart dining table. I hope people got some experience in order to some experience in applying these intelligence dimensions. That means how you are going to propose a smart system. In this case, system is smart dining table. System is table, dining table. The same procedure you can follow for any kind of system. Okay, that may be of a system of your interest, which is your project, uh, your problem statement, semester problem statement. Also, you can define as a system, and then you can apply smartness to it and see what is going to be emerging out. So that is what you are going to do in defining or designing intelligence in different systems. Okay. So in this class, we are going to discuss about, you already seeing some PPT, right? So we also covered the discussion about this particular slide, where we try for some expected behavior, which are mostly driven by the function. But that behavior should be very, very close to structurally supported behavior. So this we discussed in the last class. That means we are always trying to design some behavior which is supported by the structure. That's the reason why in this particular path, you can follow the method that you can use metaphors and analogies of human or living or natural systems for designing intelligent systems. So in designing intelligent system, you can take metaphors, you can take analogies, you can take inspiration from natural systems just to make these structurally supported behaviors. Okay, to make structurally supported behavior, which are also your expected behaviors. So you are reducing this separation. Okay, so that is where you came across the metaphor based intelligent system design. What is metaphor? It can be any kind of natural system, any kind of biosystem or non-biosystem, but it should be a natural system in the universe. Any system you consider. Okay. So if you take it as a metaphor or analogy or inspiration, then from that you can design intelligence for your particular project or for your particular system. That is fine. But immediately you will ask me what I need to observe in that inspiration or in that metaphor or in that analogy. Okay. So if you ask me that, what is my answer? Okay. So that is what we are going to discuss in this class. Suppose if I ask you, take inspiration from nature and build or design your own intelligence for your system, then you consider inspiration. Suppose you take some tree as your inspiration for your particular system. But what you need to understand in tree? What you need to look in the tree and understand to design your own uh, intelligence for your system. That means you need to understand something in that natural system. Am I right? In that case, what you need to see in these natural systems to understand their intelligence. If you understand their intelligence, then you can understand or you can design your own intelligence. Okay. So this is what we discussed in the last class too. That is how to take the inspiration, how to take the analogy, and how to take the metaphor, and how to understand it, then design our own bio-inspired intelligence or naturally inspired intelligence. Okay. So in the first class itself, I indicated you that why I am teaching this course, because we are working on using natural systems. So that's why our laboratory name is also Bio-Inspired Research and Development Laboratory. Okay. So we take inspirations from natural systems or nature, then we build concepts. Here also you're doing this is same thing. I'm asking you to take one metaphor or inspiration from the nature, then observe its intelligence, then design accordingly, which is suitable for your system. Okay, so that is what we are doing. Definitely, you will ask a question, what I need to observe in that inspiration, what I need to observe in that particular metaphor, what I need to observe in that analogy, analogical system. Okay, if you ask that question, this class is an answer. We are going to discuss the answer in this class. Okay, because one more point I would like to add here is, if you ask what I need to understand means you are asking me how to measure that intelligence, because I am asking you to understand the intelligence of a natural system. Okay, fine. Understanding intelligence of natural system means you are measuring intelligence. Okay. So now the second question comes, how to measure the intelligence, because everything you want quantitatively. Am I right? So that's why you are measuring the intelligence. So that answer also we are going to have in this class. Okay. Please remember, this metaphor based intelligence system design is based on considering some inspiration from nature or considering one natural system as a metaphor which is suitable for your problem or system. Okay. Then in that you are understanding its behavior or in understanding its intelligence. That means you are understanding natural systems intelligence. What does it mean? You are understanding natural systems intelligence means you are measuring the intelligence. Am I right? So how to measure intelligence? That question definitely will arise. What was the first question? Definitely you will ask me, sir, okay, I will see all the natural systems. Somewhere the other way, I will choose one natural system which is suitable for my problem or project. Then in that system or in that natural system, in that biosystem, in that metaphor, what I need to see, what I need to observe, what I need to understand. So that is your first question. After understanding this, how to measure that intelligence? This is your second question. So we are going to answer these two questions in this class. Okay. Now, so is my slide changed? Please check and let me know.
Yes, sir.
Yeah. So now, as per your first question, when I say please take one inspiration from the nature, then work out, understand its behavior and intelligence, then design your own intelligence for your system. Okay. Then what you need to observe in that particular natural system? If that is your first question, Ashby, one scientist called, his name is Ashby. The Ashby worked on this kind of problems. Okay, he's a very good scientist in behavioral sciences as well as intelligence sciences. So he worked on that problem. What he did is, if you consider a simple terms called equilibrium and amplification, if you are able to see these concepts in the natural systems, he proposed that you can actually understand what is intelligence. Okay, it's very simple, right? Understanding intelligence in terms of what we know very well. So now you tell me, what is equilibrium? So have you heard about equilibrium, or is it is a new term? Have you heard about equilibrium? Anyone? So what is the definition of equilibrium? You can speak. Why only 58 members are there? Too many people absent, it seems.
Yes, sir. Many members are saying that there are too many links in the channel. They
Okay,
are in the
that's
wrong meeting, it seems.
maybe just let us post. But now there is only one meeting, I think, right?
Yes,
Your
sir. I
meet,
don't know. They are in some wrong link, it seems.
but no other meeting is there here. All meetings are over. They can join now. What is there? They have to join in the classroom. The meeting link which started by me. So I posted there, but I don't see any other meetings. So that's why you always use Smart Product Design B2 2022. So that link you have to join. Generally, I join there itself. I don't start separate meetings. Okay, we can't do anything because there are no people at all. Can't help that. Right. So in that case, your first question will be resolved by. So what is equilibrium? That's a question I think I have asked. So what is equilibrium?
Sir, a balance between two things.
What are two things?
Uh,
Equilibrium means definitely a balance. What it is? Balance? It's not complete. Can you please elaborate or complete?
So
Anybody
balance
else?
between input and output.
Balance between input and output. What is that input and output?
Sir, if,
Can somebody elaborate?
sir, if we
Yes.
consider a system in equilibrium stage, there will be no change in state or any physical property.
Right. So equilibrium basically a state. It's a state. Okay. What kind of state it is? It is a stable state. That means a state of stability of the system. But here one question comes. Now it is clear, right? What is equilibrium? Equilibrium basically a state of a system. What kind of state it is? It is not excited state. It is not a deviated state. It is the state of stability, or it is a stable state. Okay, that is what equilibrium is meant by stable state. So how the stability is coming? How you are defining the stability? Anybody? Stability in terms of what? Stability in terms of what? Anybody? So generally, mechanical people or electronics people or somebody, you actually study stability in terms of force. Am I right? So in terms of force, how you define equilibrium? I'm giving the hint. Can somebody tell? In terms of force, the parameter called force or physical quantity called force. In terms of force, how you define equilibrium?
So when
Anybody?
net force acting on a body is zero.
Very good. When net force acting on a body is zero. Am I right? So if you have a parameter or if you have a physical quantity, in terms of physical quantity, you can define stability, stability of a system. That means that is called mechanical equilibrium. That means you are defining the system's equilibrium in terms of a physical quantity called force. Okay. If the net force is zero on the system, then the system is in equilibrium in terms of force. Equilibrium in terms of force. So can we define any other kind of equilibriums like this by using any other physical quantities? Any other physical quantities? Force is one physical quantity which you can say that which you can say in terms of force, you can define stability of the system if the net force is zero. Like that, with other physical quantities, can you define equilibrium? Any idea? Any guess?
So energy and mass
Energy,
and mass.
mass, definitely. In terms of mass also you can define equilibrium. Am I right? So input mass should be equal to output mass. In that case, your mass is actually constant. Any other thing? Energy, how you define? So when you say energy, I have a doubt that what kind of energy it is. Because you have mechanical energy, you have electromagnetic energy. Yes.
Generally, for energy point of view, we consider potential energy. Sir.
Potential energy. So with respect to potential energy, can we say it is in equilibrium?
Yes, sir. If the potential energy of the system is at minimum, so at that point, equilibrium will be there.
Right. That means system try to stay at minimum potential all the time. You must know, I think you must already come across this one. Am I right? So this way, in terms of energy, you can define the equilibrium. In terms of force, you can define the equilibrium. In terms of heat, can you define equilibrium? Because heat also a kind of energy, right? Have you heard about thermal equilibrium? What does it mean? Thermal equilibrium, or is it a wrong word? Have you heard somewhere?
So thermal equilibrium in the sense like there will be no change in temperature, sir.
There is no change in temperature. Very good. So that is in terms of thermal energy. So this way you can define equilibrium in all cases with respect to different parameters. Now you tell me, why always the systems want to be in equilibrium? Why systems want to be in equilibrium? Or before that, I will ask one more question. Is there any example for thermal equilibrium? You know? Is there any example system that always maintain thermal equilibrium?
Sir, heat exchangers.
Huh? Heat exchangers of what?
Sir, a thermoflask may maintain thermal equilibrium for some time.
Thermoflask may maintain equilibrium for some time. Yes. Any other example?
Human body.
Yes. Human body. How it is?
With the environment.
No, no. How you say it is maintaining thermal equilibrium?
There is no, there is no temperature difference in between environment and our body.
Correct. Correct. So our body temperature always should be how much?
So normal body temperature is 37 degrees centigrade.
37 degrees centigrade. Am I right? Suppose if it becomes 39, what happens? What you call that state? If it is 39, what you call that state?
So we call it
Okay.
as fever.
Fever.
We call it as fever. Am I right? Is it equilibrium state? Can your body stay permanently there?
The body tries to
No,
reduce
sir.
its temperature.
Body again try to reduce its temperature. Body always try to be at 37 degrees. Okay. So even though increases, that state is called fever. Okay. In the fever state, body cannot remain for longer time. In the fever state, it wants to again roll back to 37 degrees. So that's why 37 degrees is the equilibrium state where body is trying to stay. Okay. So too much fluctuations body cannot bear. If too much fluctuations comes, what happened to the body? If too much fluctuations come, what happened to the body?
So body starts deforming, sir.
Yes. Body, definitely you say it is diseased or body start what you say that it's a danger for its existence. It cannot survive at non-equilibrium states. So that is the point I want to make. So every natural system try to be at equilibrium state. Every natural system. So because it is staying at equilibrium, why it is staying at equilibrium? Because for survival, it has to stay at equilibrium. Otherwise, it will destroy on its own. Suppose if you stay with fever for a longer period of time, body may die. Am I right? It cannot stay at a higher level of temperatures. It has to stay at equilibrium for its survival and existence. So this is the basis. Any natural system you observe, you see how it is maintaining equilibrium. So in order to maintain equilibrium, it has to do something, because somebody said that the body will try to get back to the normal temperature 37 degrees. Am I right? In that particular case, body trying on its own, or it has some intelligence that will actually make it to try. It has some intelligence. Okay. That means if you understand the concept of equilibrium in a natural system, you can understand the concept of intelligence. That is the basis of this proposal. So that is the basis of this proposal. Because Ashby, the scientist whom I mentioned previously, Ashby proposed that using the simple concepts of equilibrium and amplification, metaphorically, in the case of natural systems, you can understand what is intelligence, and you can also quantify the intelligent behavior. Okay. So now equilibrium is required. Equilibrium is the state of a system which is stable. Equilibrium is nothing but stable state of a system. In order to maintain that stable state, what this system is doing, you can observe that. In order to maintain that stability, what kind of functions the system is using, you can observe that. How functions are changing with respect to time to maintain the equilibrium, you can observe that. If you observe all these things, that means you are understanding the equilibrium state of that natural system. Once you understand the state of that natural system, equilibrium state of that natural system, by default, you are understanding different functions, how they are varying with respect to time, and what is the pattern of functionalities. These all things will come as understanding of behavior. Once you understand that, designing similar kind of behavior is easy. So that is where all the algorithms called anti-colony optimization or something different algorithms came like that only. Okay. So once you understand that the equilibrium in any natural system, then you will understand that what is the behavior to sustain that equilibrium state. Because any system going out of equilibrium will cease to vanish. Okay, they will vanish, they will destroy themselves. So that's why systems cannot stay in non-equilibrium states for longer time. Maybe for short period of times they may stay in non-equilibrium states, but longer period of times it is very difficult to stay. That's why any natural system you consider, please try to understand the concept of equilibrium in that particular natural system, and also try to understand, in order to maintain that equilibrium state, what these systems are doing, what kind of functionalities they are actually implementing, how functionalities are changing with respect to time, and those patterns, if you observe, you are actually observing behavioral design of that particular natural system. Okay. So if you are defining pattern, means you are measuring or quantifying the intelligence, because you are defining the patterns. So you are measuring or defining the intelligence. This is what. Okay. So that is what about equilibrium in the natural systems. Any natural system you take in the universe, everything actually shows the sign of equilibrium. Everything like to stay at equilibrium only. Because if any system go away from the equilibrium, will cease to death or will vanish, will destroy on its own. Okay. So that's why equilibrium is very important in natural world. That's why if you understand that equilibrium in the natural world, you will understand what kind of designs you can make in order to create equilibriums in your system. Okay. It is always trying to maintain that equilibrium. All the game is going on is to maintain the equilibrium in any system. Right. The second one, because I told in order to maintain the equilibrium, system must be doing something. In order to do something, it must get some information from outside, right? From the environment. So in order to get the information from the environment, what it has to do? Okay, that is where the concept of amplification will come into picture. The concept of amplification says that, what is amplification? The general definition of amplification, anybody know? General definition of amplification. Amplification. These are all 8th class stuff I'm asking. Anybody?
Increasing the size or quantity.
Increasing the size of physical quantity. Okay. Anybody can elaborate something on that or make it explicit or clear? Amplification. Anyway, you are coming to campus. So next onwards, directly I will ask you. Yeah. Go ahead.
Multiplicating the quantity, amplification.
Multiplicating the quantity. What do you call the term you use for that?
Sir, if any quantity is to be taken, then for suppose if frequency of
your answer is correct. Okay. What is the term we use in order to say that multiplying the quantity? We call it as magnification. Okay. So magnification is the process creating the process called amplification. Amplification is nothing but magnifying the quantity.
yes.
Magnifying the quantity means the quantity is of something, it is increasing to some other level or multiplying to some with some factor. Okay. So that is called magnification factor. Okay. So magnifying the quantity is called amplification. What is the quantity here you are considering in the case of intelligence? The quantity is information. The quantity is information intensity. So intensity, how you define generally? Intensity. Have you defined intensity in electronics?
It's a power upon area.
Sorry?
Power divided by areas.
Power divided by area. I'm asking in electronics, in a wave. Wave, how you define the intensity? You are talking about electromagnetic light. Can I say intensity as amplitude square? Is
Yes,
intensity
sir.
related to amplitude? Will you agree with me?
Yes, sir.
So if the intensity is related to amplitude, you are actually increasing the amplitude of the signal. Am I right? So that is what you need to do. So can you observe amplification? That means how information intensity coming to the system is increasing. What kind of information it is using, or what kind of different informations it is gathering in order to maintain the equilibrium. Because ultimate target is to maintain the equilibrium. Otherwise it will die. So in order to maintain this equilibrium, you need to collect a lot of data or lot of information. From where it has to collect the information?
The environment.
From the environment. So from the environment, if you are collecting the information, that information intensity should be highly magnified. So in order to magnify the information coming from the environment, what are the different ways you will follow? Suppose if I ask you, I want to just increase the information coming from the environment. Okay, then what you do? How human body receiving the information from environment? Any idea?
Through the
Through
senses.
sensory nerves.
Through the sensors. Am I right? How many sensors we have? One 25. How many sensors we have?
5.
5 sensors, right? So we have 5 sensors, only 5 sensors. Let me say. Okay, only 5 sensors you have. You are receiving some information from the environment, and I am asking you, you have to increase the magnitude of the information. Then only it is called amplification. Okay, how you are going to increase this information through your sensors? Tell me. Is my question clear? Information is coming from the environment. You are receiving the information from your sensors or through your sensors. If I say you increase the information intensity or amplify the information intensity, what is the approach you follow? Is there any way to increase the information? Because you have only 5 sensors, right? So sensor number is fixed. Sensor number is fixed.
I think we need to increase the efficiency of the sensors.
Sorry?
Efficiency, sir. Efficiency of them so that they can get the more information.
So efficiency of the sensor to collect the more information. Okay. Any other approach?
Amplifiers, maybe.
No, can you please elaborate on how you are going to increase the efficiency of your skin? I want you to increase the efficiency of the skin in next 10 minutes. Please do that. Pawan?
Sir.
Yeah. So please increase the efficiency of your skin. Is that possible?
No, sir, but artificially we can apply some creams like
No.
that.
I'm asking about the human body. You talk about the human body.
So we can, so like.
So kindly don't think, please. You're all, I think, in second year, right? Kindly don't think we are so humans are creating a really supernatural system. The sensors which humans are creating not even equivalent to 1% of what nature created. Believe me. Okay, because somebody said artificially we'll create. You can't even reach 1% of what nature created. Okay, so kindly don't overestimate the human capabilities. I'm asking about the human body. Your number of sensors are fixed, only 5. In that case, I'm asking you to increase the information intensity you are receiving from the environment. Then what is your approach? You tell me. Yes. Are there any methods to increase the information? Are you getting any idea? Because you have only 5 sensors. So yesterday one of your friends said that, sir, we will use the same sensor for longer period of time. Will it increase the information intensity? That means one sensor I'm using longer period of time. Will it increase the information intensity?
No, sir.
Why? Because overall, if you consider 10 minutes you are using one particular sensor to gather the information, overall data you are getting is more only, right? Am I right?
But sir, time is also like
But you have to spend more
more
time.
time.
That is one approach. Still, we can't say that it is wrong. No, it is right approach only. But you have to use the sensor for more longer period of time.
So like we can reduce the like contact time. Like
No, if
basically,
you
sir, like
reduce the contact time, intensity also will reduce.
like we are hearing some sound at a larger distance, so we can
Hmm.
move closer to the source of the sound. So this way we can increase the intensity of that sound coming to us.
You are again misunderstanding. I don't want to increase the sound. I want to increase the intensity of information. Your understanding of information itself wrong. I am telling information flowing from environment, that information you are gathering by using all sensors. Okay, all your 5 sensors. So how to increase the intensity? One is use your sensors for longer period of time. That means extended period of time you have to use, so that the information you received is going to be high. Okay, is there any other way? Is there any other way? All the famous methods came now. Your machine learning, deep learning, artificial intelligence. Where these are all coming from? So these are all coming from the concept of increasing information intensity. The basic concept is this one only. So in order to increase the information intensity, is this only sensors playing the role, or can I analyze the same kind of information in a different ways and interpret it in a different manner? Okay, so that is where your machine learning is coming into picture, or got some significance. Okay, so for intelligence, in the intelligence point of view, if any system want to maintain its equilibrium, it needs to receive, or continuously should receive, the information from the environment, but it has limited number of sensors. When it has limited number of sensors, it has to deal with the information which it received in a certain point of time. In that particular case only, the concept of understanding the same information in different perspectives will come into picture. So when you understand the same information in different perspectives, in different ways, you are actually understanding the same environment in different directions or different ways. Is that going to be useful to tackle with this environment or not? Because same information I'm getting, whatever information I'm getting from the environment, I'm not only understanding with respect to one approach or one method. I'm using several methods in order to understand the same information in different ways. So information is my input, but output is my interpretation. So by using my methods and analytics, I'm actually bringing different interpretations with the same information quantity. What does it mean? What does it mean? Actually, I'm considering the same information into different interpretations. I'm making same information into different interpretations. In that case, it is actually equal to increasing the information. So both approaches are possible. The first approach is increase the duration of sensor working. So you receive more information. Based on the information, you have to use more information in order to take decisions to maintain the stability. Okay. At the same time, there is a second approach, the famous approach. Now everybody using. What is that approach? I receive the limited amount of information, but that information I analyze in different ways. And I will come with different interpretations of same information, different ways of interpretation. In that particular case, it is actually equal to dealing with more amount of information. Okay. So these two approaches sees that based on high amount of information or based on high amount of interpretations, then you can make decisions which will make your system or keep your system at equilibrium. Eventually, your system is trying to keep everything at equilibrium because it has to survive. So that is the reason why if you take any kind of approach in these two, that means you can use more number of you can use sensors for longer period of time, so you receive more information directly. Or if there is a case of limited information availability, you use your analytics in order to, that's what we are doing actually. Your whole bunch of neural networks is emerging from that only. Okay, I analyze the information in different perspectives. Okay, I analyze the information with in different perspective. Okay, so in that particular case, I am going to understand the same information in different ways. When I am understanding the information in different ways, that is equivalent to amplification. That is equivalent to amplification. That means less amount of information, but still because of my analytics, I'm actually getting more interpretations. But in the case of in the first case, more information intensity, more interpretations. More information intensity, more understanding. But here I'm using less information, but more interpretations, more number of interpretations. So that is where actually you are getting your concept of machine learning, neural network, deep learning, many things. Okay. So once you have interpretations, then definitely the decision will come out. But the decision is always to maintain the equilibrium. So that's why information, the amplification process is very much needed in order to make the decision. That decision is very much needed in order to maintain the equilibrium. Now you tell me, if you think generally, everyone, if you think generally, if information intensity is more, whether the decision is going to be better, or if the information intensity is less, decision is going to be better. Which one is your option? Better decision means the decision must help the system to maintain its equilibrium. That is called better decision. So what do you say? More information intensity is needed or not needed? Anybody?
So,
Yeah.
so if more information we will be receiving, then probability of getting the good result is higher as compared to when we are getting lesser information.
Very good. That's it. That's a general knowledge. That's it. So it's a common sense. Okay. So if you receive more, if you have better understanding of the environment, you can survive there. That is what this is. So if you receive more information, that means if the information intensity is high, your decision will be accurate. Your decision definitely help you to maintain the stability or maintain the equilibrium. If the information from the environment is less, then your decision won't be accurate to maintain the equilibrium. So with that, system may collapse at some point. Okay, there is a less chances that it can maintain the equilibrium. That's why here we have a direct relation between the intelligence and information intensity. Directly, I can propose, as I stated in the PPT, directly I can propose the information intensity is proportional to intelligence. Sorry, intelligence is proportional to information intensity. If information intensity is high, that is, if your system is able to amplify the information coming from the environment, then your system, the probability for a accurate decision is high. So it can take very accurate decisions, but all decisions for what? To maintain the equilibrium. So that's why intelligence is proportional to information intensity it is receiving from the environment. If the information is corrupted, then decisions will go wrong. Those wrong decisions will make you unstable or go away from the equilibrium. This you must remember. If you want to create any kind of smart product or any kind of smart system, you must understand the information it is receiving from the environment should be maximum. But I'm not saying it doesn't mean that you use more sensors. That's a stupidity. Even though you are using less sensors, you need to approach with the concept of amplification. If you are able to amplify the information, so information intensity is high, so that your system can make accurate decisions to maintain its stability or equilibrium. That may be static or dynamic. Okay, so that is what the relation between intelligence and information intensity. That means if the system want to maintain its equilibrium, it should receive the information from the environment. It has to amplify the information it is receiving from the environment. Then it has to make the proper choice to maintain its stability. Okay, then you say that it is adapting to the situation, it is adapting to the environment. Okay, so that case, actually you can say it is intelligent. Am I right? So that's why intelligence can be measured or intelligence can be quantified through this information intensity. Where is this information coming from? From the environment of the system. So if you want to create the smart systems, please remember that smart system must be receiving all the relevant information from the environment in the real time. If it is receiving all the information in real time, it can take appropriate decisions to maintain its stability, while completing the tasks. okay, while completing the goals. Okay, so that's why here we are, the scientist Ashby proposed that. Here you can see that Ashby on mechanisms of mind. Okay, if you or somebody interested, you can read that. Okay, mechanisms of mind. Ashby proposed that metaphorically you can understand the intelligence of any system by observing its equilibrium and what it is doing to maintain its equilibrium, and what are the information intensities flowing through this medium or flowing into the medium or flowing into the system from the environment. Okay, so that is what you need to observe. So any natural system, if I give you, what you need to look at, first you need to look at what are the equilibrium, what is the equilibrium in this particular system, and in order to maintain that equilibrium, what it is doing. Okay, so in order to maintain its equilibrium, what kind of information it is using. Okay, so if you understand these things, indirectly you are understanding the intelligence of that system. Okay, so that is what proposed. The intelligence is directly proportional to information intensity. Okay, because in this semester everyone going to build smart systems or smart products. That is the reason why I will request everyone, please think about the information intensity that your system has to receive from the environment. If the information intensity is more, it can make appropriate choices or decisions based to maintain its stability or equilibrium while achieving the goals. Okay, once it go away from the equilibrium, your system will fail. So that's the thing, equilibrium and amplification. So you must understand these two. Next is, I'm going to give you a system. You just have a look at this system. So what is this? Is the slide changed? Please confirm.
Yes.
Yes, sir.
Yeah. So in this system, in this, what is the system you think?
Sir, bud.
So this crow is the system. So this crow is the system. Then every rest of the things is environment. It is trying to achieve some goal. I need not to explain what it is. From the image itself, it is very explicit. Am I right? So in this particular system, okay, can you understand equilibrium and amplification? Please analyze this system with respect to equilibrium and amplification and tell me how you understand the intelligence of this system. Okay, so that is what today's class assignment. Okay, so I will share the assignment with you, but here please try to understand. You have to explain what is the system you see in the image. You have to explain what is the environment of that particular system. Okay, then goal anyway you know very well what it is doing. Then you please try to tell what is the equilibrium mean here in the case of the system, and how you define the equilibrium elaborately. Okay, so how equilibrium is maintained from information intensity. That means what kind of information it is receiving from the environment in the real time. Okay, so with that information, what kind of actions it may do in order to maintain the stability. Okay, please observe this thoroughly and write down how you are going to understand the equilibrium and the amplification and information intensity in this particular system while achieving that goal. Okay, so hope nobody will consider that crow is getting bath there. What is the goal there? Anybody?
So to drink the water from the tap.
Goal is to drink the water, not getting bath. Okay. Good. So analyze the concept of equilibrium and amplification in the event, in this system or in this event. Okay. So what is your system? Crow. What is the environment? You can define. And finally, you tell me how you understood intelligence is proportional to information intensity. Okay, please do that. So you have to define the equilibrium of the system. You have to understand what kind of amplification or what kind of information is flowing into the system, and how is the information intensity or amplification is happening. Okay, these all things you can write. So please understand equilibrium and amplification in this event. Goal you know very well, system you know, environment also you can define. You can imagine something while defining the environment, no problem. So eventually you must realize, or you must come to the conclusion how information intensity and intelligence are connected in this case. Okay, so that is what the assignment you please start doing. Okay, I will be available from 3:30 again. So if you have any questions, I will address them. Okay. So I will just share the assignment now, but please do it elaborately, because you don't make it like a definitions. Okay. I just want to see, are you really understanding what is mean by equilibrium in that particular system, in that particular case? Okay. So that is what I want to see. So assignment is shared. You have to submit it by 5:30. Okay, you have a lot of time. Please sit and apply the concepts of equilibrium and amplification. Then you please try to complete the assignment. From 3:30 onwards, I will be available again. Okay. If you need any discussion, we can do that while doing the assignment. Okay, start doing. I'm just stopping the recording. So this video you can keep for your